Hi Nana, good morning. In this lecture I am going to explain you about Bohr's postulates of atomic model. Actually, what is atomic model according to Bohr? So according to Bohr, every atom consists of the orbits whose energies are stable. The energy of each orbit won't changes. It remains constant. Okay. So according to Bohr, the first postulate is electron in an atom will revolve in certain orbits without emission or absorption of energy. Okay, whenever the electron is revolving in this orbit, okay, it won't emit any energy or absorb energy. Okay, so these energy levels are known as stationary states. This is first postulate. And coming to the second one, the angular momentum is some integral multiple of h by 2 pi. What is this h? H is Planck's constant. H is where this h is Planck's constant. Planck's constant, and whose value is 6.6 into 10 power minus 34 joule second. Okay, this is Planck's constant, 6.6 into 10 power minus 34 joule second. So the angular momentum of each orbit is integral multiple, where this n is an integer. So integral multiple of h by 2 pi times. Okay, and coming to the third one, so if I had given some energy to this electron, okay, what happens? This electron will absorb this energy. Okay, this energy is nothing but the energy of phonon, PHONON. Okay, if I had given some energy, okay, to this electron will absorb this energy of phonon and get excited to the higher energy state. Okay, then after you will find out the absorption spectrum here, and if this electron loses the energy, nothing but the energy will be emitted. Energy is emitted here emitted spectrum. We will observe emitted spectrum. If this electron loses its energy and moves towards the lower state, okay, then you will observe the emission spectrum. Okay, and the energy of this emitted spectrum or the energy of this emitted electron will be equal to phonon energy. Okay, this energy will be equal to phonon energy which is emitted, and this will be equal to h nu. Here energy is equal to h nu, which is nothing but initial energy minus final energy. What is initial energy? So in this orbit, okay, if initially the electron is in this orbit, okay, I will explain here clearly. Wait a second. Okay, if this is the ground state, energy E0. Okay, first excited state E1, E2 is the last excited, second excited state. If the electron is in second excited state, okay, if this electron emits energy which will be equal to energy of phonon h nu, okay, and the initial energy is E2, and after emitting this energy it will move towards the first excited state, which is E1. Okay, therefore this h nu is equal to E2 minus E1. Okay, the emitted energy is nothing but the difference between the two energy levels, these two energy levels. Okay, so the energy emitted is equal to E2 minus A1. This energy is nothing but phonon energy which is emitted. Okay, these are about the three postulates of Bohr. These are the three postulates of Bohr's atomic model. Okay. And in my next lecture, I will give the radius, Bohr's radius, which is known as Bohr's radius. Okay, I will give you the radius of each orbit, the relation for radius for each orbit, and also for velocity and potential energy and kinetic energy and the total energy of each orbit. Okay, then bye.